Hey everybody, how's it going? Hopefully you can hear me all right. I think you should be able to because I can see the mic moving. So I just don't want to repeat what happened last time. How's it going, Voxriffs? Good to see you. So today we're going to be adding Lua scripting. Technically Luau. I'm not sure if that's how you say it. It might be Lua, Luau. But this is basically the Roblox version. And although I don't like the way Roblox operates, I don't like them just because of the different things that they've had with their company. This is a good language. It's used for a game engine and it works pretty well. They have certain things that are nice about it, such as sandboxing. So they have like a sandboxed environment, which means that you can kind of like separate scripts from each other and have it a bit safer, because it's always a risk when you're injecting user scripts into some sort of API that actually interfaces with C code or C++. So it's got some nice stuff. But yeah, I've gone ahead. I've already added it. Let's go back up here. I've already added it, sort of. So I've just gotten it like set up, gotten the code, and then got their test kind of code up here and running. I think it's working, but that's what we're going to be finding out, is if it actually is working, because technically I'm not quite sure. So they basically show kind of this example, and they say return main chunk main function. And so I'm not sure if we're supposed to call that afterwards and make sure that's actually working. But we're going to find that out today. So we're just going to kind of mess around with this and hopefully get it working. In terms of where the engine itself is at, or I guess the animation editor, last time we were working on this circumscribe animation, which I got finished. I still have to add support for like bounding boxes across entire game objects and stuff, or animation objects, but the animation itself is working fine. So you can have either no fade, which means it just does this kind of wrapping, and then if you increase the time width, you can kind of increase how wide that line is, like the length, and you can go all the way up to 1, which just means like it finishes its rotation before it starts like unwinding. And so it looks kind of cool. You can also change the buffer size. So like if I go here, I'll do fade in so that we can kind of see that. You can increase the buffer size, so you can make it like bigger or smaller. 0.25 looks pretty good, so that's what I've got it at. And you can also have it fade in and fade out. So if it fades in, kind of does that. And the fade in, fade out, the time width doesn't matter because it's fading in, so you don't really have a width. So I just kind of disable that if you're doing any sort of fades. And then fade out does the reverse. So getting that animation was actually a lot easier too than I thought it would be. I was way overcomplicating it at first. If we go over to animation.cpp, we can actually take a look at it. Oh, we're in here already. Cool. So getting this to work right was actually a lot easier than I thought. Let me take a sip of coffee. So essentially what you do is, first of all, I determine if it's fading or not. If it is, then I have to do some different stuff. I added this new API, which basically allows you to create a path, and then you can render that path as an outline with a start t and an end t. So basically, like, what percent do you want to start from and where do you want to end that outline? And that's what this does. And then the real magic happens here, where we basically do that kind of a little width of a line. Basically, you have this, we push the color, we create the path, which basically just does a bunch of move tos or line tos and stuff. So if we actually look at create rectangle, you can see it's just doing a line to here. So nothing fancy there. And then what it does is it figures out the start t, and then we go 1 plus the time width, and we remap it to a 0 to 1 range again so that we get the full animation. And then we basically just subtract the time width, and it creates that cool little animation. Kind of got to think about this one for a little bit, but yeah, it's great. And Voxers, by the way, you should upload your imgui.ini. It's a pain setting that up. Yes, I really should. Thank you for reminding me. That'll be something in the future where basically I'll add like presets, you know, It'll come with a default preset, which is whatever mine is, and then I'll have it. It's kind of hard because I have a wider monitor, and the way that imgui.ini works, if we take a look at it, is a little bit, it's not the greatest. Let's see, where do I have it saved? There we go. So yeah, it actually uses like pixel sizes. So you can see that we have position 3055, 1345, and then this is 7. That's because I have, because it uses, and so since I have a wider monitor, it's not going to scale correctly on other people's monitors and stuff. Which you can see especially from this. So I've got to figure something out. There's a few different posts about imgui. I want to make it so I can just like write some code that writes up the default initialization and kind of dock stuff manually, but it's a little bit of a pain, so just haven't gotten around to it. Anyways, though, so that's the circumscribe animation. We also have the ability to do circles, which I forgot to show. So if I go here, I can also do, we'll do no fade again, circle shape. And so if we do a circle shape, it just circumscribes it in a circle, which is pretty cool. The buffer size is very big, so it goes pretty far around. That's a little bit better. So yeah, pretty happy with the way this turned out. I've just got to fix up some stuff, and then where it basically you don't have to add it to the sub object, which is what you have to do right now. Got to fix that, and then once that's all done, it should be pretty usable. But yeah, so we've got this, and now I want to work on Lua scripting. Basically, I want to be able to, not sure if it's going to be an animation or like, I'm probably going to have an asset editor or something here, like assets. And then you can create scripts and stuff, because that's probably the best way to do this. And then you can open those scripts or whatever. And then you can drag those scripts, or you can drag an animation, probably more likely, which will be like script animation, right? And then you drag your script into that up here, kind of like we do for dragging objects and stuff. But first, we have to get scripting working. So that's why we're doing this. And I'm trying to figure out how we can test this. So basically, if we look back at the documentation, I want to wire print to some function that we have, which I think we should be able to do. Let's see. Like the Lua print function too is what I mean. I want to wire that to like some sort of function that we have control of. Let's see if we can just look that up. So this is based on too, by the way. The Roblox API is based on Lua 5.x. So yeah, it's got slightly different syntax too, I guess. So this is like the documentation for getting correct things, but for the most part, it uses the same API and everything as Lua. Let's do how to print Lua C. Yes, this is what I want. Cool. You can redefine the print statement in C. So Lua my print, you get the args. And so the way Lua works, by the way, is a stack. So you push different things onto the stack, you pop things off the stack. So to get the number of arguments, you have to pop the stack to get that, and so on and so forth. Pop the next arg and do your print, then register it in the global table. Yeah, so then you just put it in this global table. And I wonder which, because this is 5.x, but it doesn't tell us which one. So if it's greater than 5.2, we got to be careful. Which... Okay, so it looks like it's 5.1. So apparently we would want to do this one. So we get the global, which this is our global table. And then basically what that does is it puts on top of the stack. And when we do Lua register, it puts this new registry into that global. Okay, let's try this out. So, and of course, we're going to make this a little bit better eventually. Right now, I'm just kind of throwing everything into here. Eventually, it's not going to be this bad. So, print wrapper Okay, so we get the args, pop this next arg using Lua to string li and do your print. Li. Okay, and what does this return? This returns, I'm guessing const char star string. Yes, okay, cool. So we get a string, and then what I'm gonna do is say, for now, glogger info, but in the future we'll probably have like a console in the animation editor itself and stuff, so you can kind of debug things if you want. %s lua log str. All right, do something with non-strings if you like. So if it's not a string, we have to convert it to a string. There should be a way to do that too. I believe there is. So this is the API with all of the stuff you can use. There's a lot of functions in here. Thankfully, it's not too many functions, but it is quite a few. And I think there's something in here that's like that we can convert other things to strings. Oh, it returns 1 if the value is a string or number. Okay, so this gives it for strings and numbers, because numbers are always convertible to strings. That's interesting. I'm wondering, though, if we can do like a toString method that converts things. If not, it should be fine. We should be able to do yeah, I think we'd have to do something a little bit more complicated. We have two Boolean, two C function, two integer, two L string. Converts the Lua value to an acceptable C string. If length is null, must be a string or number, otherwise it returns null. That's interesting too. Okay. Yeah, so I think we'd have to do some extra stuff in order to get non-strings to work. W.I. Plary, what am I doing? I am adding Lua scripting to my animation editor. And Mr. Good Day, wow, I want to offer promotion of your channel. Of course you do. Here, let me just remove this very quickly. Streamlabs is supposed to give me a way to do that, but for some reason it doesn't work. So I'm just going to go into Twitch itself and remove this. If I knew how. Apparently I don't know how to do this stuff. Let's see real quickly. No? Okay. I guess that one's staying in. Oh well, it doesn't matter. Okay, so yeah, we're adding Lua scripting to my math animation editor. So right now I'm overriding the print function because I have a Lua script here where I basically want to see if this is correct. So what I'm going to do for now is I'm going to say else if Lua is bool. Yeah, is boolean li. We'll at least add like a couple other helpers for tables and stuff. I'm not going to worry about that yet. So for this one, we're going to say bool value equals Lua to boolean. Yeah, I think that's what we do. Okay, I think that's what we do. So we would do that, and then we would say glogger info Lua log %s, and then we'll just say val true, otherwise false. So we'll just kind of do that conversion inline there. Booleans, we have numbers. I think that's fine for now. And then tables will be later. We'll put an extra log here. Logger warning. Tried Lua log tried to print non-string or boolean or number value. Okay, just in case. So we got that. This returns an int. And then how'd they say to use this again? And the reason it returns an int, by the way, is because with Lua, like I said before, everything is a stack. So when you return 0, you're basically telling Lua after it calls that function that there's no return values. Print is a otherwise you have to like tell it how many return values there are and all that stuff. So yeah. Okay, so we do that and then we need to register it. So we'll just copy that. Once again, we'll make this nicer eventually. So we'll do this. Actually, I'm gonna move it above this stuff. And now I'm gonna have to forward declare this. Okay. Why is this not happy? Print lib. Incomplete type is not allowed. It's not an incomplete type. Is it? Okay, so that exists. What is this not happy about? Lua L reg. Is this not a complete type? Let's see. Lua L reg. Yes, that does not exist. We've got Lua register, registry. Yeah, okay, so that's interesting. No, it shows the type though, which is weird. Just not sure where it's getting it from. Oh, maybe I just don't have it included here. Let's see. Let's do, what was it called? Common? Common slash, no? Okay, let me see. There's a lot of different libraries in here and I can't remember. I might be missing some include. Let's see. Although I wouldn't think so because I don't think it matters, but who knows? Common, yeah, include. So maybe common.h. No, doesn't look like it likes that either. Okay, interesting. Does he say anything else in here? Since you're using, you'll need to use extern C. Okay, one last thing I'm going to do then to make sure that this works right. That might be it too, the fact that I'm not using extern C here. Let's do that, and then we're going to put our code in there. Which is right here. Nope, that still doesn't seem to fix it, so something else is wrong. That's fine though. Lua C API. Function registration table. Okay, so they say Lua L lowercase reg. What does he say? Yeah, it looks like that's right. Okay. Interesting. Let's try his approach. I really should be looking at the API and stuff and just like actually figuring out how this stuff works, but it is what it is. Lua C function. I know I saw C function signature somewhere in here. Okay, somewhere up here. I wish they had like a getting started or something. Okay, yeah, so Lua C function. There we go. Okay, so we've got a function pointer. We've got Lua state. We'll just Lua state. All state. I think I did that wrong. Lua capital state. Okay. Push C function, which expands to push C closure, which expects, okay, what does that expand to? Lush. Okay, so that turns into Lua push C closure. I'm trying to see what this function call is expecting. Let's just jump into here. Okay, there we go. So what does this expect? Lua C function. Yeah, that's correct. And then a Lua continuation. I don't think we need that though. I think that's optional. So why does it not like that? Lua state function debug name. Ah, we need a debug name. So we can just give that the function name. Okay. I have no idea if this is going to work, by the way, but we'll try it. So we've got this register C function, and we should call this register global C function, because that's what it's doing. So we're going to do that, and then we're going to say register global C function. We're going to give it our Lua state, table name, so this is expecting like, okay, here, let's see. Lua get globals table. C API. I think it's just underscore G. Yeah, I think it's just this underscore G. Okay, let's try that then. So we're going to say underscore G, and then we're going to call this print, and we're going to give it our Lua print wrapper. Okay, let's see if this works. So if this does work, we should get like Lua logs now, because we're calling this function. Like we're running this code is essentially what we're doing, I believe. Because basically we compile it, then we load it. That's also a different thing about Luau, other than Lua, that's different from Lua, is you have to compile stuff. But it's also nice because when you distribute things, well, I guess we don't really have to worry about distributing this stuff since this is just meant to be run locally. But if you did, you could distribute the bytecode instead of distributing the raw scripts and stuff. Anyways, we load it, and then it should run the code, I think. Let's see what happens. Okay, we'll build it. So we got success, question mark, but nothing happened. I don't think I'm actually calling the code. Okay, let's try Lua call 0 args. I don't know. Maybe that's what we do next. Because I'm not sure. I think it might just be loading. Okay, so what did that do? That says Error code 2. What is error code 2? Does it tell us what the exception is? Let's continue. Nope, no exception. Okay. I wonder if this is something we could try and then catch that exception. I don't think that's right, though. I wish they gave a little bit more than just, like, literally, this is all they give us is, oh, to integrate it into, you'll do this, and then you'll just create a new state, and then you load it into the VM like this. And then they just show this, but they don't show how to run it. For more details, Luau close trackly, but has a few deviations. So it's loaded into the VM, Luau VM. Do we have something? So we have compile, run. I don't know. We'll check it out in a second. I will be right back in like 5 to 10 minutes. So I'll see you guys in just a few minutes and we'll continue. All right. Sorry about that, guys. So, I did look up something, though. How to run Lua script, C API. And it looks like we just need to do... Well, I thought I found something. Here we go. One of these. How to... Resuming Lua script. How can I call Lua scripts? This one. It looks like all we need to do is say Lua pcall. So, yeah, let's try that. So this is just the compilation result. So we can say compilation succeeded. And then we're going to say Lua pcall. We're going to give it our state. 0 args. Lua multi return. And 0 for our function. And I think that should be fine. And then we can say if result equals 0, logger info run succeeded. At least I think that's how it should go. Right? So pcall, if result, yeah, so that's if it failed. I guess we can do this too. So we'll do that. And we'll say error. Failed to run script, and then Lua toString, and that's if the result is non-zero, so we'll do that. And what's wrong with this? This returns toString, should be fine. Why is this not happy? L is undefined, that's why. Lua state. Okay, so I think that's all we have to do. Let's try it. Oh, okay. Failed to run script. Global env attempted to call a nil value. Okay, well, that's good. That's something. So I guess we are trying to run it now. Global env tried to call a nil value. Where? I wish it gave us a little bit more than that, but I'm guessing it's talking about the print function, maybe? Not quite sure. Let's see. Lua global env attempted to call a nil value. I copied this script, so I don't think the script is wrong. I guess we can also do this. Do I have Lua installed? Lua? I don't think I do. CMD, Lua. Yeah, I don't think I do. I think this is happening. I guess one way we could check this out is just by doing this and commenting these out. Let's see if it works this time. Okay, so it did work that time. So it's definitely the print. At least I assume it is. We can do one more test. If we do this, it should still succeed. Let's just double check. And it still does. Okay, so it's definitely the print function. So it doesn't like our print function. Oh, I wonder if it's our register global C function. Let's put a breakpoint in here and see what's happening. Let's see if we can debug this a little bit better. So we go into here. We get this field. If it's not a Lua table, it's creating a table. Okay. So this already doesn't seem very good to me, because I would assume the global table already exists, but maybe not. I don't know. So let me push print. What does our Lua state look like? I wonder if it gives us our globals here. GT, global table, maybe. Yeah, okay, so then we have meta table, which is null. Or I guess global is probably the one I want to look at. Okay, let's see. Yeah, I don't see anything in here that looks like tables. Nope. Okay, what about up here? Yeah, don't see anything that looks promising. So I wonder, I think it's this. I don't think this is right. Let's see. Lua, add new global print function, C API. That's not what I want. That's not what I want either. Okay, yeah, so they're doing this registry thing again too. And I wonder why this doesn't work. So then they do... Oh, I wonder if it's just because we're missing this, which also is different. Hash include. And we don't need all that. Let's do that. This actually does not exist. I think it's lualib.h for Luau. And then I wonder if we can get our registry. So can we then do lua l reg? Okay, now this exists, it looks like. So static const lua l reg global functions equals print, and then we're going to say our print wrapper. Okay, and then null and null. Okay, so now this is working. So I was just missing this include before, which is why it wasn't working when we tried to do it last time. So instead of doing this, we're going to do that. Get rid of this breakpoint, and then how do we register it? I don't want a new library. Let's see. Lua C API custom print function. That's not what I want either. That's not what I want either. Let's just do Control H and see if we can find that first one that we had, because I think that actually was right. I think it's this one. It is, because I still have it open too. Okay, wait, is this the same thing? Yes, redirecting, redefining. Okay, so I had it open already. Okay, so we get global. So this is what we want to do. Let's try this. Except we're going to get rid of that. And that's going to be Lua state, and this is going to be our global functions. Is what did I call this? I did. Okay, cool. And then Lua pop, Lua state. Okay, let's try that. See if this works. Of course, I need to uncomment these too, so that would help. And Lua print wrapper undeclared identifier. What did I call this? Lua underscore print wrapper. Okay, try again. And does it work this time? No. So now we get an exception again. So this is what happened last time, I think. This exception is coming from here. Okay, it's coming from Lua L register. And if we go into here, it's an index error, attempt to index. Yeah, so it looks like that global doesn't exist or something is what I think is happening. I think this doesn't exist. It said to use this one for 5.2 or greater. Let's maybe try this. Yeah, I don't think this is it because it doesn't look like it even knows. Yeah, this is undefined. Okay. So yeah, what's happening here is what I'm wondering. Underscore G. Lua get global meta table. CAPI. And this is Lua 5.1. Maybe we should start with this. Okay, let's try this real quick and see what happens. This supposedly iterates through all the globals. Lua state, Lua state. Okay, push global table. No. Okay, let's see if we have it. Push global. Oh, wait, that was because they had that as a macro. Yeah. Okay. So this should supposedly print out all of the globals. Let's see if that actually works. Okay, it looks like it did. Yeah, so that looks correct. So I'm wondering if we just need to do this. Wait, underscore G is a global within the globals, is it? Oh, it is. Thank you. Yes. Okay. That's good to know. So get global underscore G. So this should work then, I would assume. I wonder if we can do this. Push value globals index, push nil. Can we do that then? And then maybe that will give us everything inside of underscore G. No, I'm gonna break stuff. Okay. Let's see. We want to print out this table. Lua print table CAPI. So we get, and then we push nil, which is what I did, and then while Lua next. Yeah. While Lua next, Lua state -2. That's right. Put S, Lua 2 string, Lua state -2. Wait a second. Okay, so if it's a number, I think that's basically what I was doing before with that register C function, which is now gone. Or wait, no, up here actually. Yeah. Oh man, this is, I really should have learned this a little bit more before trying to actually dive in, but we'll get somewhere eventually. Hopefully, I'm just trying to do a print function, and this is difficult enough, I guess. Push C function, L my print. See, I'm wondering if it's just because I'm using, what was this? Push Lua L register. What if we do Lua push C function? Okay, and then we said Lua state. Function is Lua print C, or Lua print wrapper, and then we just do that for print. And then let's just do this. Comment that out. See what happens there. Nope. Attempted to call a nil value again. Function debug name. Lua push. Yeah, I'm not sure. Okay, let's go back to the tables because I think that is important. Okay, so he has a print here. Open libs, push C function, my print. Oh, and then you actually have to set it afterwards. Let's try that. Okay, wait. So I'm going to go back. We're going to try this one more time. Okay. And we're actually going to do that. Lua push C function. Okay, and then Lua, what was it? Did I copy it? No. Lua set global, which should set whatever's on top of the stack to print, I think. This is after we open the libs. So let's do that again. Okay, try that. No, we just get, oh wait, okay, this is a different error though. Oh, look at that. Okay, we got Lua log true. Okay, cool. So that works. That's good to know. Why does it work? don't know. I think the problem we were having was I don't know why they were sending it in _G when it looked like print is above that scope. So yeah, I'm not sure why they did that. But it looks like this is working. Let's try this again, because I want to see where we're getting to in the script when it fails. So we get Lua log true, and then we get line 4 attempted to compare number less than string. Okay, cool. So it even tells us like what the script was. Compare number to string. That is here. Okay. So it's not happy about that. If we look at what they say here though, so note that there's no warnings about is positive with a string or calling is foo a number. This is because the type checking uses non-strict mode by default, which is lenient. So then if we add a bang strict, it should throw errors. And then the analysis should flag it. We don't have analysis going on right now, but I wonder what happens if we try and do this. And I actually probably have to put it up there. Let's see what happens now. Does it compile it, or does it throw a function out, or throw an error? Okay, so we didn't get any errors. Compilation succeeded. But I wonder if we can call the analyze API now. So before we compile, maybe, is there something called Luau analyze? No, I wonder if I can include it though. Analyze, code analysis, Luau / analyze. Nope. Compiler experimental flags. Let's see, where does this live? Let's go here. Here, analysis. Okay. So we have analysis include. Oof, that is a lot of stuff. Okay. I think this is what we want though. Does it have something? No, it doesn't have like a top level thing. I wonder if maybe there's a function that I'm missing that's included in like lua.h or something, or luacode.h. Lua analyze? Nope. Luau. Oh wait, we have compile options. Compile sources by code. It'll throw an error. What are compile options? Lua compile options. Okay, let's see what this looks like. Oh, so we can even, oh, cool. Optimization, baseline optimization. That harm debuggability. Oh, cool. We can even debug stuff too. That's pretty cool. So apparently I can embed a debugger. This, yeah, that could be very cool. And even this null terminated array of globals that are mutable disables the import optimization for fields accessed through these. Sweet. So then I can even add my own globals, which is probably something we're going to want to do. We'll want to have our own API that kind of interfaces with certain functions that I provide, and we can add them in this mutable globals. Sweet. Okay. Well, that's interesting. That's not what we want, though. Does Luau load? No. Luau analyze C API. Don't think this is it. I was reading through that earlier. I don't think that has what we're looking for. I wonder if it is in one of those functions now, or like those header files. So we have compiler, and this has those two things. We have VM, we have common, codegen. I think it would be in this analysis, which makes sense. But I don't see any file in here that seems like it would be like the one that you include. Front end, maybe? Front end or module? Not sure. Let's just try it. Okay, let's go into here. We're gonna add, there we go. We're gonna add analysis, which I think is what that was. Okay, analysis. That's correct. Cool. So we're gonna do that /include. And then I'm going to go ahead and rebuild this. Let's see what we get. Okay, reload this. Now I should be able to include Luau / and I'm looking for, what was it? Front end, possibly. Let's see what this looks like. Of course, I can't find it. Okay. Luau. No, this isn't going to be good. Okay, let's go ahead and just open it up because I need to see if there's anything in there. So go into here, analysis, include. Oh, documentation.h. That's helpful. Okay, this file is part of the Luau programming language. Okay, blah, blah, blah. Documentation. Oh, that's interesting. So wait, there should be documentation about this then. Wait a second. Okay. Let's go to library. Maybe it's in here. No, that's not quite what I want. Where is their C API? That's what I want to know. Let's go back up to their top level. How's it going, CGO clan? Good to see you. A little late today, no problem. Okay, here we go. The linting passes are described here, and the type checking can be found here. It comes with a set of analysis tools. Okay, maybe this is the right thing, I guess, then. Let's see. Nope, these are just functions that we can use. You would think they'd have a little bit more. I don't know. It's kind of disappointing. They have this documentation.h thing, so you would think that would show a little bit more, but I'm wondering if that's for like writing Lua documentation inside the Lua code. Let's take a look at front end real quick. If they don't have a C API for this, I wonder why they wouldn't, because it seems like something that you would want. I wonder if we get it. No, this just gives us that. CGO clan, could you do ChatGPT for me for once? I guess you already signed up. I have not signed up, and I'm sorry, I can't do ChatGPT on stream. That's not the topic of this stream. Sorry. Let's see. Got that. You would think they would just have some documentation, but I'm guessing Luau analyze. Okay, so it looks like you can. Access their analysis tool. Okay, wait, it's a bit involved. The error gives and takes location, comment.h. Maybe we have to import comment.h. Let's try that. Luau/common. Maybe it's in here. Nope. Lua analyze. Nope. Okay. Wait, if you want to build an interface to the type checker in another language, wouldn't it be worth it to reflect the whole interface? File resolver. And invoke its check, lint, and mark dirty. Okay, so I guess all we need is front end. So I was right about that at least. Let's include that again. So Luau/front end. And is it in a Luau namespace? Front end. Okay, here we go. So I think this is what we want. Front end. And we give it a file resolver, a config resolver, and front end options. So what is our file resolver? Let's try that first. Luau. I think this is basically going to be like just a way to find files. Wait, let's see. File resolver. Yeah, so I think this is literally just a way to, like, you give it a directory to look for files in. This is a pure virtual function. Okay, wait, so file resolver. So do we need to null file resolver? Let's do that one. Sounds good to me. We don't need a file resolver, so we'll give it that. Sounds good to me. Initialize that there. So give it that. And then we need a config resolver, okay? Luau null config resolver. Just 0 initialize these maybe. Config resolver. That's happy. Why is this not happy? So this is of type file resolver. And it looks like it should be fine. But it's not happy. No instance of that matches that. Wait a second. This extends this, which is good. And this extends this. And since it's a struct, it should be public by default. That's weird. I think it's because it doesn't override these, maybe? Wait, no, it only needs to override this one. Interesting. Oh, I just have to give it that, maybe? No. Weird. Okay. We'll make our own then. So let's do this real quick. Namespace Luau. Struct null file resolver extends. We'll call it my null file resolver. And I'm just going to explicitly make it public, even though I don't think that matters. And then we're just going to go ahead and implement that. Okay, return stood null option, which is what they were doing. Source code. Is that right? No. Let's see, what were they doing? Yeah, return stood null option. That's all you gotta do. Okay, cool. So let's try my null file resolver, see if that works. Oh, maybe I have to cast it? Yeah, okay. Let's do this. File resolver equals luau null file resolver. And what's wrong with this? Okay, there we go. Now it should be happy. But it's still not happy. Why is this not happy? Matches the argument types Lua file resolver, which it is. Maybe I just have to do the same thing here now. Okay, try that. That should be star. Okay, there we go. Now it's happy. Cool. And then we just want to make sure delete file resolver, delete config resolver. And then we can get rid of this. Cool. So we've got that. And now we have a front end. Front end dot check. And we can give it a module and option overrides. What else can we give it? A source module. Mode, environment scope, require cycles for autocomplete. What else do we have? Front end dot. Type checker? No, that's just a member. Check, lint, and mark dirty. Yeah, so I think we just need to check it now. For that, we need a module and we need option override. Let's see what module. Lua module. No. I would think it's just this part now. Front end. Okay, front end dot check. We can give it a source module and an environment scope and require cycles. So luau source module, which does not have any sort of constructors. Let's see if we can go into here and find. Okay, root of the AST of a parsed source file. Okay, Luau parse, maybe? Nope. Oh, maybe it's this. Read source. Resolve module. Man, they're not making this easy. Let's see if we can find something else, maybe. Wow. Example analysis of source module. Nope, that's not what I want. Man, you would think they'd make it a little bit easier to just do this stuff, but I guess not. So they have read source, which gives you source code, resolve module, get human readable module name, get environment for module. And I wish I could just... What does this do? Compile. Oh, I'm not going to be able to find that. Man, I'm about to just say it would be easier to launch a process and then just pipe the std error output into my output than trying to use their API. That is not intuitive at all, but I don't think that's true. Yeah, so I think we basically would have to actually get file resolver to work. Let's go into here. Cool trick, by the way, in case you didn't know, if you go into GitHub and you just press dot, is it not going to work? Dot. Try it again. Nope, maybe it's control dot. It should open a VS Code instance. GitHub VS Code instance. And the reason I'm doing this is because I want to actually see the definitions of these functions. No. Oh yeah, so you should just be able to press dot, but I guess since I don't own this repository, I can't really do that. Okay, that's fine. Let's go into here. Source. I'm wondering if they have an example of a file resolver that actually works front end. Okay, parse path. Okay, so what does this do? So this looks for the module. Then it uses that module. So you have to load the module in first, is what I'm assuming is happening here. Let's see. Where does it look for that again too? I just saw that. Okay, so name, we have that here. Okay, so source nodes.find. So this source nodes is what they're looking through. I'm guessing that source nodes is if we look and include front end source nodes. Where is that coming from? Okay, so this is a source node. And we've got a module name to a module pointer. Oh, this is front end module resolver. Okay. I wonder then if we could just add a source node in here, but I don't think that would work the way I want it to work. So let's go up here. I think we're just going to have to override this properly. Wait a second. Can I just use that? Front? Nope. Module resolver dot, or I guess arrow, resolve module info. Don't think that's quite what I want. Exported only for convenient testing. Man, this is way more complicated than I was hoping it would be. Nope, that's not what I want. See, I wish I knew how this is supposed to, like, what is source code and how are we supposed to return that? Let's try this. Okay. Actually, we'll just do struct my file resolver extends Luau file resolver. Okay, and then we're going to override this one. Okay. And we're going to do that. So this is going to be a result. and it has no constructor. So what does this have in it? Local, which is source code type. Ah, okay. Maybe this is way easier than I thought it would be. So let's just say type equals res.module and then res.script. Or no, sorry, res.source equals, go ahead and just hard code this in here because I'm just trying to figure out how this stuff works. Test source code. Turn res. We're just going to hard code this single one. It's not actually going to do anything. I don't care about any of this stuff. And do we have to do res.module? No, res. I think that's it. Just this. So if we give it this now, okay, we're going to say that, and then file resolver, read source, foo. It's going to return us an optional Lua source code. Okay. Then front end dot check. Foo. I don't know. Let's just see what this does. Okay. Have no idea what's going to happen here. I think since we have it just hard coded to return that single thing, it's just going to always return that source code regardless of what the module name actually is. So I don't think it actually matters here. Otherwise, I think what we would do is like overload that module resolver, file resolver to actually go through a directory and return something. Peepo Ren, thank you for following. Good to see you. I'm really hoping this works because I have no idea what else we could do to make this work. But if it does, that's good because we at least have a start and I can hopefully make this a little bit better and automate it all. And then we can get analysis plus compilation, which is what I want for this. And compilation is going to take a while. Also, I fixed a lot of the warnings. I remember in the last stream, we had a bunch of warnings because I increased it to level 4. But I didn't fix all of them. So most of them are gone now, which is good. There's still a few, though, that I have to keep fixing up. And it warns me of a lot of good stuff. So, like, increasing your warning level to warning level 4 gets you things like, oh, you have this function that's not actually being used anywhere. If you have static internal linkage, which is stuff like this, where basically you have a function that's internally linked, and if it's not used anywhere in the file, it warns you about that. And so things like that are super nice. It also tells you about variables that are initialized but not referenced, which is also good because you can go through your code and, you know, sometimes you change things and you forget that this variable isn't actually used anymore. And so there's lots of things like that. Cannot open source file. Why can't you open these source files? Luau parse options, AST, dense hash. Okay, so I think we just need to add some extra include directories so that this does not break. So we're going to add AST. I'm just going to add all of them because I think that's probably the best. So analysis, AST, CLI. I don't think we need CLI, but yeah, let's just try this. I'm going to try, I don't want to add unnecessary stuff. So we're going to do the minimal, wait for the long compile time, and then continue. Okay, so we rebuild. Now we wait again. I also tried to upgrade my single include implementations file thing for my utility functions with like memory management and stuff. I had forgotten that I switched that to C instead of C++, and I used designated initializers, which C++ does not have, but I found out C++ 20 does have designated initializers, which is pretty cool. Do they have the C++ website? Documentation. You'd think they'd have it on like their actual website. CPP documentation. No? Okay. Well, anyways, designated initializers are just this thing. So if you use C++ 20, you can actually use kind of this C-style aggregate types or whatever. I don't know. It's cool. So I upgraded to C++ 20 because that is a feature that I actually think is extremely useful. And I'm glad that they actually added it. I really hope we don't have to include anything else, because if we do, I'm going to have to recompile this again, and it's going to take a while. Almost there. Hopefully you guys are all going to have, if you celebrate, a good Christmas, which is coming up. I'm excited. I have the next 2 weeks off, which is why I'm streaming now on a Monday, so that's kind of nice. Almost there. I've been watching, I don't know if you guys know Andreas Kling. He's the guy who made Serenity OS, and he has a massive library, and so he'll often like start compiling it, and then he'll go and do other stuff while he's waiting for it to compile, which is nice. We've got unresolved external symbol. Let's make our own config resolver. I think that's what's happening. So struct my config resolver. Config resolver. Yeah, that's right. Luau. Oh. Two colons there, and we should be good. And then let's go to here. Gonna override that. Okay. That's gonna return that. And that. And then we're just gonna return a default config for now. Config, res, and yes, there's nothing fancy there. Enabled lint. So that's lint options. Mode. Is this... Okay, fatal lint, globals, lint errors. Parse options. Okay, I think this is what we want. Which takes in parse options. Parse options. I guess we don't really care about that. Okay, what about res dot? So this is a lint option. Can we set lint options anywhere in here? Let's see what this says. Luau mode. No. Res.mode, which is of type luau mode, or config mode. Yeah, I don't know. We're just going to return res and 0 initialize this. Let's try that. And then we're going to go ahead and just make that new. Make sure that's marked as override. Why is this not happy? Expected a semicolon. That's better. Okay. And then let's just make this like that. And we should be good. Nope, we're still not good. Okay, what's wrong with this now? Oh, I might not be linking to these. Wait a second. Okay, let's see. So I am linking to, if we go into here, links, that's not what I want. Okay, so I've got the CodeGen. No, I have AST CodeGen compiler VM, and I don't have that like a dummy. Okay, let's go ahead and make sure that's linked. I just want to make sure this is correct. So if we go into here, build, we have, let's go to debug somewhere in here. There we go. AST, CodeGen, compiler, VM. Do we have analysis? We do. Okay, so I'm going to add analysis. And we're going to rebuild. Okay, do that. Cancel that. And go back into here. And we're going to recompile again. Hopefully, though. Okay, cool. So that didn't actually trigger recompile. And we actually did something. Awesome. Let me just adjust my microphone and let's see what happens. Voxrus. Man, I can't imagine Rust compile times with a project this big. Yeah. I have not used Rust, so I'm not even sure how the compile times compare and stuff, but probably wouldn't want to try either. Okay, cool. So it looks like it's just going straight to our file resolver, which should return that test code. Okay. So then we go and try check, and then we get an exception. Why is this exception? Get with type. Can I do try or something? Let's see. Try catch Luau exception. Error. AST type error? Maybe? Yeah? Okay, let's try that. Error dot... I don't know. Can I just do auto? No, it does not like that. Auto is not allowed here. Does this... Check. Okay. New shininess. That does not help me at all. Okay. Check result. Yeah, so I wouldn't expect it to throw an exception. I'm not quite sure how C++ exceptions work, if they like show or you can find exactly what kind of exception it's throwing. Parse error. We've got type error. Parse results. Check results. I don't know. Let's do this. We're going to say check result res equals that. This is going to be... I guess we should probably see what we actually get there. So for now, I'm going to say luau type error. We're going to do that. And then g logger error. There was a type error exception. I don't think that's actually going to do anything, but I want to see what exception we get when we go through that, and then we can try and catch that. Okay, so we go over that. Okay, what is the exception we're getting here? Access violation reading 0x blah, blah, blah. Yeah, that's not good. Okay. So we're trying to get name something that doesn't exist. Get module environment. Okay, so I think we actually need to set up an environment or something. Front end dot add environment. Okay, that's probably what we need to do. Global or foo test. I don't know. Let's see if we can go into read source up here. Yeah, there's no way for me to specify like the environment of that. Front end dot. What else do we have? Why did you just disappear? Can we just add like source modules here? Oh yeah, maybe we do like source modules dot insert, and then I'm gonna give it, or I guess we could just say this foo equals file resolver read source foo. At least I imagine that's how it's supposed to do. Dot get or dot value. What's wrong with this? This says, what do we get? Oh, this is source code. Luau source module. Module. Dot. We have name, parse errors, root, type. I wonder if it's this module resolver is what we're supposed to use for that. So front end dot module resolver. Resolve module info. Yeah, this is not helpful at all. Man, you would think they would make this somewhat intuitive, but it's not at all. Like, I am at a complete loss as to what the best way to do this is, because their documentation sucks and they have absolutely no hopeful things in here. Get source module. This does what? Returns null pointer if we don't have it. This could mean that the script doesn't exist or it's changed. Okay, so how do we add a source module is what I want to know. Try to convert an AST into a module name. How do I actually get a module though? That's what I want to know. Nope, that doesn't matter. Let's see. Was it this that I was looking at? I think so. Nope, that's not what I want. Let's do, I wish I could go into this compile, because I have a feeling that probably takes it through Well, no, I don't know if that would take it through analysis. Man, I no idea what I should be calling here and stuff because they don't tell you anything. One thing I do know is that we don't actually need that try catch. I was just doing that wrong. So, yeah. Okay, let's check again. So if we go into here, compiler, VM, analysis. Let's go back into here, front end, and let's look at check. Okay, here we go. So first it tries to find it within source nodes. Let's see if there are any functions that add something to source nodes. Okay, so we do have something here. What is this function? This is get source node. But this requires source nodes to already have it. Okay, so that doesn't help us. Okay. Yeah, so that's not helpful at all. Let's go, I'm going to do one more thing. Let's go into here. No, let's go into build. And I'm going to take a look at analysis, which is right here. Actually, let's just open up the whole solution so that we can actually search for things and stuff and see if we can figure something out. Okay, so analysis. What I want to do is look for where we use front end. Where is front end? There we go. Okay, so we've got front end here. Let's go to here. Where is this used? Find all references. Okay, so it's used in front end, which makes sense. It's also used in CLI. So this is probably a good place to look. How do they use it in CLI? Yeah, let's take a look at this. Analyze file. Okay, this is where I should have started. Man. Okay, so we have check result. We have front end. We have a name. We have report format. And we have annotate. So if the source module doesn't exist, okay, so if it can't get it, which basically means that it tried to open the file, but it couldn't find it, then it says error opening the file. And that's it. It just does that. And then it says for error and errors, report error. What? Oh, I guess that's just in case there was an error opening the file or something. I'm not sure. Then we have lint result. Okay, maybe I was overcomplicating this. Wait a second, though. Let's check and see. CLI file resolver. Okay, let's see what they do in their file resolver. Which actually I don't think matters. Maybe. Okay, so they do source code type. Okay. Then it returns the source code, resolve module. We might have to copy that and tweak it. Okay, and then they have CLI config resolver, which I don't really care about. Okay. So how do they construct their front end? That's what I'm looking for. So we have front end options. Then we have their file resolver and their config resolver, and we initialize front end to that file resolver and config resolver and options. Okay, then they do this. I don't know. Let's see if that helps us out. So we're going to go here. Nope, we're going to go here. Get out of this. So they do that. Then they do this. Where is register built-in globals coming from? This is coming from, what file are we in? Analysis include built-in definitions. Okay, so we need built-in definitions. Let's go back here. I want to make sure I don't lose this. Okay, so we're going to analyze. Okay, so if we go up here, I should be able to say include built-in definitions. Cool, so we've got that now. Then they get source files, and then they just analyze every file. Okay, so wait, let's take a look at analyze file one more time because it just seemed way too easy. And I'm really annoyed if it really is this simple. We literally just say check result CR equals front end. Oh wait, no, okay, so they do front end dot check. Okay, so they do call front end dot check and it works for them for some reason. Let me copy this. Okay, and then we're going to go back into here. Yeah, so I have the same thing here. I have this res equals front end dot check. So this is essentially what they do. They say CR, the name, which we're going to say is const char star name equals foo. Doesn't really matter. Okay, we'll do that for error and errors, and then let's just see how they're reporting them. Okay, I'm just going to copy this. And we're going to paste it up here. Oh, and then they have another report. What does that look like? Report. Okay, we're just going to copy this too, and we're going to put it in there as well. And they have a report format. Where is that coming from? That's coming from here. So we're going to copy that too. Okay, cool. So now it works. Where's format coming from? It's coming from this. And if we look back down here again, format was down here. Format default. Okay. So let's just do that. So we're going to do that. And that should be fine. Okay, cool. So now we have this, except it's going to fail as soon as we do this. Watch. So if we go into here, at least I think it's going to fail. If it doesn't, then I'm going to wonder why it's working now when it wasn't working before. But let's try this. So we go here. Yes. And then we get an exception thrown. Okay, that's good. That's what I was expecting. So let's see what they do to make sure that exception does not get thrown. So they have front end options, retain full type graphs. How exactly do they? So they have assertion handler. Don't think that matters. Okay, so then they have this file resolver, and they have config resolver, which takes in what mode? Okay. And this has a cache and everything. Interesting. Okay, that just returns the cache. I don't think this stuff really matters too much. But it could, and I could be completely wrong there. Okay, what about CLI file resolver? Because that's really like the only other thing that I could see doing something different here. So this gets the source code, sets the source type, and then it just returns this, which is essentially what we're doing here. Except I'm just hard coding it. Yeah, so I'm just saying the type is a module and then doing that, which really doesn't matter. At least I don't think it does. What does this read file do? Okay, that just reads a file, which makes sense. Yeah, so I'm not sure what's happening here that's like doing something extra. Oh, wait, they're overriding resolve module and get human readable module name. I wonder if we need to override these as well. Let's try that. Okay, we're just going to use this by default. Okay, let's see what happens now if we override those two things. Nope, we still get an exception. Okay, one other thing they do. Well, actually, so do they override other stuff in here? So this is not overriding anything, and neither is the other stuff. This is the last thing I can think of to try that they're also doing in here. So they do this, annotate. What is annotate? Just false. Okay. And then they pass in front end options here. Let's try this. No, we're still getting an error. That's why this makes no sense to me. So they have the options, then they have their resolvers, and that's it. Then they have their front end. And then they just go and call analyze file for each one, which does this. Makes no sense to me. Let's see if we can go ahead and try to actually run this and step through their code. So this is CLI, right? This is, where are we? And we are in CLI Analyze. Yeah, actually, let's go into here. Never mind. Okay, yeah, let's go in here. And let's go up to here, and we're going to say build options, somewhere up here, properties. Let's see. Oh, wait, actually here. Command line? Can we do this? No, that's just the, okay. Wait, how do I have, let's see. There should be like something like run options or something like that. Debug. Maybe it's in debugging. Oh, here we go. Yeah, command arguments. Okay. So let's see. How do we do? Just pass in some code. Actually, you know what I'm going to do is I'm going to go to here, cd to desktop, make file. Can't remember what it is in Windows. It's going to be easier to just do this. Okay, new file. Let's call this test.luau. Where did it go? That's what I want to know. There we go. Okay, and then we're going to go ahead. And we're going to paste this into here. Okay, and then just rename it to that. And then I'm going to copy the path. Where is copy as path? There we go. Okay, and then we're going to say command arguments is that. Apply. Then we're going to say debug. Okay. So we have two arguments, and the first argument is the program, and the second argument should be our file. So let's see if this works. Okay. I should probably run it first, just see if this works. Type error, string could not be converted into number. Okay, so this does work. Now let's try and see what exactly they're doing that we're not. Okay, so let's step back into this. Okay, so we go through that. They set up their front end. They do all that stuff, which we're doing too. Then we get our source files. And then we go into here, analyze file. Okay, so that pops into here. Okay, so we get front end check. So it finds the source node. Wait, does it? Okay, if source node does, if IT does not equal end. Okay, no, so it doesn't find the source node. It parses it. Yeah, and then it goes through all this stuff. I wonder, does this do something special? Where is it? This get all files or whatever, get source files. Does this do something special? No, okay, that does nothing special. Okay, so this should just, it looks like it should work the same as mine. Let's try mine now. Let's see if we go through sort of the same path. Okay, so we go into here. Okay, so we go into here. It skips that. We parse the graph successfully. We go through module name, which is foo. So that looks right. We get a source node foo, all that stuff. Okay, and then we fail here. Wait a second, which one was that? That was, no, that's not what I want. Check, okay. So we fail when we say mode.value. Oh, config.mode. The one thing that I said didn't matter. Maybe that does matter. Wait a second. Is it as simple as just going up to here and actually, you know, setting the mode like we probably should have in the first place? Config resolver. Okay, mode, which is strict. I'm going to be annoyed if that was it. If it was as simple as doing that. Let's see if this fixes it. Prepare to be amazed as I am very stupid and miss something very simple. Okay, no. So now we're failing here. Let's see. Nope, that's the same thing. Okay, maybe we're failing in environment scope. Okay, yeah, so mode is fine. It's environment scope that we're failing at. Okay. So it wasn't that. That was wrong. Let's jump back into here again. The one that actually works. Okay, and I'm actually going to do this so that we can just kind of skip to where we want to go next time. Okay, and we want to go down to here. Why do I have a breakpoint in here? Let's go back up to this. Okay, here we go. Hey, SC Woods, how's it going? So if we jump into here, I wonder if it's that environment name that's breaking things. Environment name is null option. And then we just go through. Am I doing the same thing here? Okay. That's right there. Okay, so if we jump into here, environment name is null option. But config.globals. Oh, okay. So that definitely looks wrong. I don't think we should have that many globals. Oh, it's because I didn't initialize the config.globals. Oops. Okay. So it turns out initializing your variables properly is actually important. What is globals? Globals is something called tags. Let's go back into here. Okay, config resolver. What does this do? Parse config. Lint errors, type errors, globals. So it looks like we need to initialize all of these things. Else if. Yeah, so they're going through each of the keys and trying to parse them. Okay, so we have that set, lint rule string. Let's see, where are they doing this? I guess what I could just do is go back into here. Let's say res dot enabled lint equals false. Can we just say like stood null opt? Does that work? No. And this isn't happy either. Why is this not happy? Lint options. Luau lint options. We'll do enable warning maybe? Nope, that's still not happy. What if we just do this? If we zero initialize this, let's try that. And then go ahead and try and run this again. Essie Wood, since I have you, I might ask. I remember the sound implemented in the Mario series. If you have a sound which you want to vary in decibel for different situations, did I make the engine able to handle that, or several audio files made with different decibels? I think if you're using OpenAL, you can just set that through OpenAL's audio API, but I can't remember correctly because it's been a while since I've worked with audio. Sorry if I wasn't as much help, but okay, we're still getting. Yeah, globals is still huge for some reason. That's weird. Parse configs. Do they ever do anything with the globals? Push back. That's it. Oh wait, what's default config? Oh, maybe we should do this. Was I just returning the wrong variable here? No, default config. Maybe I just need that to be persistent is what I'm wondering now. And it's just failing because it's on the stack. Let's do that. It should be public by default. Oh, this is const. So my config resolver. That, and that. Let's try that. I wonder if it's just garbage data and that's what's happening. I see what's not that. No, that made a lot of sense. I would think it should be possible. Okay, yeah, I think it should be. I'm just not quite sure where exactly that is. And look at that, guys. It's just because that was garbage data because I was initializing it on the stack instead of having it long-lived. Well then. And now we get an error. If we look in here, which is error, type string could not be converted into number. Wow, that was a ride. That was so much harder than that should have been. Oh man, they really need to just add some simple documentations that people actually know how the heck to use their dumb APIs. Like, all it would take is just a couple pages of documentation. It's not that hard. But whatever. Okay, so we finally have this working. Essentially what happens is we just needed this to be long-lived, and we can just return a default config. I don't really need to add any configuration options. We can do that stuff later. Let's just change this to glogger error. Okay, so we got that. Glogger error. Got that. And same thing here. Cool. And so now if I want to analyze something, I just want to make an easy, simple function, kind of like what they had. Analyze. We'll take in const char star source code. So if we want to analyze some source code, what do? We do all of this stuff. Okay. And we'll also take in a name. All right. And we'll also take in a front end. I guess we can take that by reference. Cool. So now we can do that, except get source module name. Okay, so I wonder if I can change this. Instead of having to resolve files, read source, we give it a module name. Is there a way we can just read? Oh, I guess there is. Yeah, it's easy. So instead of doing this, wait a second. Where was I? This is getting very messy. Gonna have to clean this up. Okay, so instead of doing this, so if we're just analyzing the source code and giving it a name directly, instead of doing get source module, which returns Luau source module, we'll say that module equals source code name. Like that. I think that should be good. Let's just double check this. File resolver, where is that? Right here. So we have type and source. So instead of this, we'll say source code. Actually, let's just see, what does this look like? Source module. We have name, type, environment name, cyclic, allocator. There's a lot of stuff in here. Okay. What does this do? Get source module. Which goes into here. I shouldn't have closed out this quite yet. Okay, let's open this back up. I basically just want to be able to open an anonymous file. So we have this, okay, which goes through here. No, wait a second. We have, before we do that, so this goes check. So I think that's actually fine. I think this is where we want to figure out some way to actually add it manually. So it basically looks to see if it's in our source nodes. If it's not, then we go to here where it builds it. So it parses the graph. And somewhere in here, it's going to go, I'm guessing in here. So when we parse the graph, somewhere it has to call the one thing, our file resolver, with the given name. So we have config resolver here. Yeah, not quite sure. Do they have a mode where you can just analyze something that's not a file? I wonder if we could just like kind of short circuit this. Okay, so we have this file resolver, read source. Okay. If we can't find a file, if not file is file or something, do I have file is file? Let's go include. Nope. Maybe file slash file. Nope. Let's see. We have math platform. Guessing it's in here. Platform. Platform. Oh, math anim platform. There we go. File exists. Okay, so if the file does not exist, we'll give it the name. Okay. Then we're going to assume it's an anonymous file, and we can have something in here, like some sort of function, void set anonymous. Anonymous. Wait, okay. There we go. File. Const string ref source. Okay, so we'll have this thing, which basically goes, and we're going to have stud string this equals that. And then we're going to say res type equals turn res. Otherwise, this is going to be math anim platform read file. No, I think we would just need to read it. For now, I'm just going to do this. To do read file here. Okay. And then we're gonna do one last thing. We're gonna say, actually set this std optional. And anonymous source dot has value. Okay. Value. So we're gonna do this, and then we're gonna say anonymous source equals null option. So this way you can only use the anonymous source once, and then once you read the source, it kind of resets itself. So all that to do, basically what we're gonna do now is when we analyze, we're gonna say front end dot, what was it? File resolver. And then we're gonna say add anonymous or something, I think is what I called it. Here we go. Tinspin, hey, did you try to make your own bytecode stack VM? No, I have not. I'm using Luau, and we're embedding that into my code, which is what I'm doing right now. So I'm just getting a file analysis working so that we can analyze our code and make sure that it's correct and report errors if we need to. Okay, wait, so we want to change this front end to my file resolver star. Gonna do that. Dynamic cast. Okay, we're gonna do that. Star. Cool. So we got that. Anonymous source. No, we want to add an anonymous source. There we go. Source code. Okay, cool. And we actually want to give it a name too, probably. So we'll pass in the name as well. Let's go add that. Const string name. Okay, we'll do that. And yeah, I guess this is actually easier. We could probably just do this. Right, so we just do that, and then and anonymous name equals name. And then we'll just do that and that. Okay, cool. So we do this. And I guess if we do want to like make sure that it's not reused, we can just set it to empty string afterwards. Just call it that. Okay, cool. So we do all that stuff. So we set the file. That should make it so that when we go and do this check, it resolves it appropriately to this name, all that stuff. And then we should be able to, yeah, we should be able to report those errors. So now with all that done, we've got this name. Okay, so then if we were to do analyze, yeah, okay, we can give it our test source code and our name and our front end. Okay, so that should just analyze it. So now if we run this, we should get errors. Sweet, so we do, and it gives us the appropriate name and everything too. Cool. So we get foo, line 718, string could not be converted into number. And if we take a look here, all the way up here, line 7, string could not be converted into number. Cool, okay. So now we have a way to analyze anonymous source code, so we can just do that, or we can actually use the file if we want, which we'll eventually go through here. And I'll probably add some extra stuff to this file resolver where basically I give it a directory to look in, and yeah, that should just work. I see what changing the sound volume was as easy as you can be. You were right. Okay, cool. Glad that was easy. Awesome. Awesome. So we have that. And then after we do that, we can actually execute the file using this thing down here, Luau call, where we basically execute the script and it can print because we've registered our own print function, and it basically tells us we failed because the number to string conversion failed. Yeah, that's pretty cool. Okay, I think that's a pretty good start. I'm going to end the stream off here since we've kind of got everything set up and we have proof of concept of where we can report errors to the users. I'll just have to like log this into the actual UI and everything. We also have a way to load different scripts, which is good because that's the start. And we know how to register global functions, which is good. So I can kind of create my own functions that wrap around C calls to my APIs. And that should be good. Like, it's all set up. I just have to go and hook everything up now. But yeah, thank you everybody for watching. Sorry that this was just a massive struggle all around trying to figure out how to get this stuff to work. But hopefully it was somewhat informative. We debugged the code. We went through their code and kind of tried to understand how it works and stuff to get to a point where we could actually use it ourselves. So happy we're leaving this off here. And just as a reminder too of where we are now, we now have a way to create different SVG files, play the animations and stuff in here. And soon we're going to have a way to have an asset editor down here, or assets, and we can add new scripts and stuff. Maybe I'll just call it scripts. And then we'll be able to use some sort of script animation object to actually go ahead and add a script animation object here, and we'll call some sort of API and everything and go with that. But yeah, as you would not continue the stream, I have a ton more questions. Bye-bye. Well, thank you guys for watching. I'll see you next time. All right.